question. I may or may not answer, but go ahead.
Okay, so on the homework, there was, what is the maximum?
Okay, don't. We're going to address all of this.
Jeez.
Yes, Paul. Okay, we're going to address all of this. Just hang on. So here we go. Let's start off with the hard one. I say hard one, and I'm saying that kind of on purpose. What are the possible values for the following quantum numbers? Well, n has the possible values of the positive integers through infinity. So 1, 2, 3, blah, 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 infinity. You can't just write infinity, because that would include all the fractional parts of whole numbers. Okay. It's been a long time since I took a math class. Is that what they're called?
All real numbers.
Okay,
Includes
not
everything.
Don't write that.
Then don't write what he said. Go with what I said. All positive integers through infinity. I think that covers it. Next, what does, and here's the hard part of the question, what does the value of n tell us? The energy level. This is the thing you've known since you took physical science. It's the only thing you've known since you took physical science, but that's the one piece that you knew. Okay. No, I meant as far as this stuff's concerned. And for some of you, maybe it's the only thing. But anyway, L. What are the possible values for L?
0 through n minus
0
all positive
through
integers.
n minus 1. So 0, 1, 2, 3, through n minus 1. Now, everybody most of you, if not all of you, wrote that down because that was what was in your notes. Here's the most important question, and this is the one piece that's causing the most people the most problems. What does L represent? The shape of the energy level. Now, when we said 0 through n minus 1, that's inclusive, right? Meaning, at the third energy level, what are the possible values of L? 0, 1, 2. Representing S, P, D. That's huge. But you guys get that. Yes.
Why are they called shades of their letters?
They have names for those shapes. I forget what they all are. Well, what are the shapes? Well, there's a spherical one, there's a dumbbell-shaped one, and there's a bunch of weird ones after that. I mean, I've shown you the shapes. I had passed a book around and said, look at the shapes.
Really?
Yeah, they were like over
Yeah,
here.
So anyway, oh yeah, in fact, I even had you guys dig into
There we
books
are.
and I showed you the F orbitals. So anyway, moving on. And finally, this is, well, I actually lied. I think the M sub L one is the L1 is the one that's been causing the problems, but then that leads to a lot of problems with the M sub L. What are the possible values for M sub L? Go ahead, Emily. Negative L through 0 to positive L. Now, here's probably the key. What does each value of M sub, and that's also inclusive, what does each value of M sub L represent? An individual orbital. An individual orbital. Where L represents orbital shapes, each value of M sub L represents a single orbital. So, for example, we'll do this. This orbital, right here, has what value of N? What value of L?
1.
What value of M sub L?
Negative.
This orbital.
2, 1, 0.
2, 1, 1.
There you go. Okay? So the M sub L refers to specific orbitals. Yes, Paul?
So when is L not n minus 1?
Say this again?
When is L not n minus 1?
Whenever,
Isn't it always?
no, it's up until n minus
Yeah.
1, so.
I don't know what that means. I don't.
Like when n is equal to 2 and then so is L.
L can't be equal to 2.
What?
The L can't be equal to 2 if n's 2.
Is it always n minus 1 is equal to L?
Is L
Inclusive, starting at 0, up to n minus 1.
Depending
It,
on which one.
listen, it'll happen, don't worry. All right, now, before I go any further, I want to do this. What changes?
The N.
Everything else stays the same, right? Okay. All right.
Oh, yeah.
This, what I'm about to do, actually happened this morning. Some students came in to ask some questions. Was it any of you as I'm looking around? I think it was. Right? It was a little mix of my first group and my second group. Doesn't matter. I started at, there was some confusion obviously with the N and the L, okay? So I started turning things around. There's a question on there. I'm going to basically ask the opposite question here. I think there's a question on there. No, there's not, but I'm going to do it this way. Now, remember when we have been doing the electron configurations, we keep adding electrons with the orbital notation until we get to the element that we're covering. Just relax. It's okay. Things are good. Okay, 1/2. Anyway, we put that last electron when we get to the element that we're aiming for. Chromium or sodium or whatever it happens to be. You guys see what I'm saying?
Yep.
So, what I'm doing here is this represents that electron for that element. What I'm asking you to do is identify the element. Ready, set, go. Keep it to yourself. Keep it to yourself. Work on it yourself. Don't shout it out. Don't raise your hand. See if you can identify what element those 4 quantum numbers represent for that last electron to fill that last orbital. Some of you are going to get this. About 2/3 to 3/4 of you are going to get this right now. The rest of you will get it after 1 or 2 more exams. All right. Kelly, do you have an answer? Okay. Jacob, do you have an answer?
I'm pretty sure I do.
Are you confident in your answer? This is a yes or no question. If you don't know,
That's
flip a
not
coin.
very.
It's like that just answered the question, by the way. That's a yes, no, or silence question. 2 of those are the same answer. Rachel, do you have an answer? Okay. Megan, do you have an answer? Are you confident in your answer?
Yeah.
Okay. Courtney, do you have an answer?
I have a general vicinity, but that's not
Do you have an answer?
No.
Okay. Judy, do you have an answer? How confident are you in your answer? Okay. Avery, do you have an answer? Are you confident? Let's go back to Judy. Judy, what's your answer? Anyone concur? Okay, I disagree. Who else feels they had, now listen, how did your life change by being wrong there? No, it didn't. Good. Good. Megan, what do you have? Anyone concur? Good, neither do I. Avery.
I had some.
Oh, didn't know that. What do you got?
Chlorine.
Anyone concur? Excellent. That's it. Now, how many of you had chlorine? Oh, that's about 2/3. All right. Here's how we do it.
In that.
Which energy level? Let's do this. Let's learn how to get to the right area on the periodic table. Third energy level. So, where are my choices for the third energy level? And be careful here, because this actually starts to answer a question that I think Paul or somebody else was going to try to ask and I wouldn't let them. We're talking
That one.
here or here. Those are my possibilities for the third energy level. Would you guys agree?
Yeah.
Here or here.
Mhm.
Now, we're at an L equals 1, which tells it to a
P.
orbital, so that eliminates this, right?
Yeah.
Because now we're here. So we're somewhere here. How many of you got it to at least that point? Awesome. That's great. Now the question becomes, which electron are we referring to?
The
Which
zero.
direction is the arrow pointing?
Down.
Down, which means that's the second time we are in that orbital. So that puts us here, right? Because we go up, 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 down, down, down. Watch this. -1, 0, +1, -1, 0, +1. We're at 0 with an arrow pointing down, so chlorine. That's pretty nifty, isn't it?
It sure is.
Let's try another one.
Like, because it's
I'm
the
actually surprised I got that first try. I just didn't pay attention.
I was like, is this for chlorine? I was like,
three,
wait,
and since it's a negative, you start like.
because
Up, down,
I
up, down.
wasn't sure if it went up,
It's like if it was a
You weren't sure if it
positive,
went up, up, down,
it
down,
would've-
or up, down, up, down, up,
Yeah.
down.
but since it was negative.
That is
See if you can identify the element represented with that electron.
Definitely chlorine.
Or in other words, where is that
Um,
electron located? And
well.
what?
Ooh.
Well, everything passed. But anyway, that's the last electron for that element.
That might be a hard one. I don't.
I think I might. Wait, never mind.
Brody, have an element? Don't tell me what it is. You have an element. You have an answer.
Yeah.
Confident? Okay. Angel, have an element? Confident? Okay. I was going to pick on somebody else. Can't remember who it was. I lost that person. Where did that person go? Oh! McKenna, have an element? Oh, okay. Amaya, do you have one? Joe, do you have one?
Yep.
Are you confident?
Yeah.
Joe, what do you got?
Tungsten.
Did I?
Everyone agree?
Why not?
I don't know if I do.
Yeah.
Okay.
Hold on. Pretty good.
Oh my goodness. Gee, dang it. It's low.
I don't think I do.
But wait a minute, it's. Doesn't it depend on the table?
No.
Because it starts here. Right here.
Okay.
These are.
Here's how I.
Because of the.
We're talking n equals 5, so where can I be?
There.
Here,
That. Or down.
here, or here.
Oh.
I'm just saying, is that correct?
Yes, that's right.
Those are my places I could be. However, L equals 2, which is a D puts us here.
Yeah.
Okay.
Why?
And we're looking at m sub L is plus 1. So remember it goes
Negative 2.
-2, -1, 0, +1, +2.
2. Can I get it?
Now, that's the position.
Yeah.
What periodic table are you talking about?
That.
I got
This
the one
one.
you just
Oh, +1? My bad, it is tungsten.
Wait,
I thought-
positive?
What?
You don't even know.
So tungsten
Oh, it
is?
was positive.
Yeah.
Okay.
Yeah.
Okay, so how do you do this?
Well, anyway,
Actually,
what I'm hoping that did is kind of consolidated the relationship between all the quantum numbers for you.
Doesn't E have 5? So when do you go to negative, like, cause when.
-2, -1, 0, +1, +2.
That's 5. And then 5 more, that's
And then you have the other five.
Moving on, let's get through the rest of this.
Oh, I wait, I
Whoopsies.
think I
Number 2. We're on number 2 now, by the way. Which of the following orbital designations are incorrect? That would be the 1P and the 2D.
Oh,
You guys probably, hopefully have that.
I have those and a few more.
You can't have any more.
Okay.
9S, fine, sure. You can have a 732,000 S if you want. I understand what the periodic table has. However, do you have an attic at home? Do you use the attic?
There's a lot of attics.
There's a lot of attics. You know what I mean? There's a lot of places that we don't keep things in.
There are
There you
infinite
go.
attics.
Which of the following set of quantum numbers allowed in hydrogen atom for such an correction? Okay. So N2 L1 M sub L -1. Is that allowed? Absolutely. B, N equals 1, L equals 1, M sub L equals 0. No, because the L cannot equal N. N equals 8, L equals 0, M sub L equals 2. No, an M sub L, an L of 0 is an S orbital. There is only one S orbital, which is a M sub L of 0. So 2, you can't have an M sub L of 2. How about D, N1, L0, M sub L2? Well, that's exactly the same question as C, so the answer is no.
Okay.
E, 3 for N, L equals 2, M sub L equals plus 2.
Yes.
Absolutely. F, N equals 4, L equals 3, M sub L equals 4.
No.
No, M sub L can't be greater than L. And finally, N equals 2, N equals -1, M sub L equals 4.
No.
No, L can't be negative. Okay.
That was really.
4, how many orbitals in each atom can have the designation 5p?
3.
That would be 6, or sorry about that, 3 orbitals.
Okay.
3 orbitals.
Because there are only.
Px,
it's
Py,
orbitals.
Pz.
It's orbitals, not
How about
size.
3d sub z squared?
1.
1. When you get that, when you're identifying one of the d orbitals, that is a d orbital. N equals 4. 16.
Dang it.
Yeah.
4d.
5.
There are 5 of them. Any d orbital, there's 5 of them. And n equals 5. 25.
Oh.
Remember that one for number 6C. Remember your answer to that one for 6C. We'll come back to that. All right, now number 5, how many electrons can have the designation 1s? Just 2. How about 3p sub x?
Also 2.
2. How about 2d sub xy?
Again 2.
0.
Oh.
That is not allowed. Can't have a 2d.
Oh yeah.
You didn't ask if it was allowed.
You distracted us with the
2p.
6.
That is 6. And 6f.
28.
18.
14. F's are always 14. There's
Oh,
7
okay.
F orbitals, 2 electrons per. That's the attic.
20.
All right, now what's the maximum number of electrons that can have these quantum numbers? N equals 4.
36.
That would be 32.
Dang it. Never get these.
N equals 5. M sub s equals positive 1/2. That is 25. Because at n equals 5, what's the maximum number of electrons you can have? 50, but only half of them have arrows pointing up.
it can be 1/2 or 1.
Negative 1/2. Either 1/2 or negative, positive 1/2 or negative 1/2.
I thought we just.
E, n equals 2, L equals 1.
No, never mind.
That would be 6. Those are p orbitals. There's only 3 p orbitals, 2 electrons per. G, n equals 2, equals 1, m sub L equals negative 1, m sub S equals negative 1/2. 1 electron. You got all 4 quantum numbers and they're valid. 1 electron. N equals 5, m sub L equals positive 1/2.
Yeah, where did you go?
Second column.
You already did G.
N equals 5, m sub L equals plus 1. Something like that. Plus 1.
All of you. Wait, did you just go down?
N equals
Yes, he
5,
went down
m sub
first.
L
It's
equals
on
plus
B.
1.
It's B.
What can you tell me?
How many are there?
How many electrons?
8?
8. How did you answer that?
Yeah.
How did you figure that out?
I
Okay,
I
good
never thought
answer.
about it.
Good answer. Good, thank you. I had someone in my first group say, I looked it up on the internet.
I didn't look
I
it up.
was amazed that you could actually look that up on the internet. No, I mean seriously. How do you look that up?
You just type it in.
Type the whole question in and it'll come up.
Well, we know
I'm going to
that.
tell you what. You try that on this one, okay? Now, the person told me it took them to this place.
Sorry.
Took them to this place. They had to sit there and look at it and figure it out. Okay, good enough. But here's how you figure it out. At n equals 5, what are my possible values for L? 0, 1, 2, 3, 4. Of those 0, 1, 2, 3, 4, which of those can have an m sub L of plus 1? All of them except the 0.
1, 2, 3,
That's
4,
4
5,
orbitals.
6, 7, 8.
2 electrons per orbital.
That makes
So,
more
fifth
sense.
energy level, we can have L of 1s here, L of plus 1s here. We can have L of plus 1s here, and then 2 other places that we aren't to yet.
I did that today.
Quiz tomorrow. We didn't have time today, as it turns out. Oh, by the way, there is a packet that is due Friday. It's a large packet. If you would like to get started on it, you can. Well, I'm trying to look for them. I would highly recommend that you do start them, but I have to find them. Here's 2.
Oh, I got that.
Called it.
It's big. You want it. I just can't find it. I don't know where they are. Well, you're going to want it.
Where is it?
I found it. Don't do number 1.